Hello friends, welcome to Math Solution Academy. Now I discuss the Wronskain of a ODE of degree 2. Now suppose a0 d square y dx square plus a1 x a0 x dy dx plus a2x y is equal to 0. This is a homogeneous ODE. Now let y1 y2 y1x and y2x are two solution of equation 1. Now what is the Wronskain? Wronskain of x equal to y1x y2x into y1 dash x y2 dash x, and this became y1x y2 dash x minus y2x y1 dash x, and Wronskain of this differential equation becomes a function of x. Now we differentiate this with respect to x, we get omega w dash, that means Wronskain dash x equal to y1 dash x y2 dash x minus y1 dash x y2 double dash x minus y2 dash x y1 dash x minus y2 dash y2x y1 double dash x. Now these two terms are cancelled out and this becomes y1x y2 double dash x minus y2x y1 double dash x, and call it equation 2. Since y1x and y2x are two solution of 1, since y1 and y2 are two solution of the given equation this satisfies the equation. That means a0 y1 double dash x plus a1x y1 dash x plus a2x y1x equal to 0. Now from this we evaluate y1 double dash, and this becomes minus 1 by a0 x a1x y1 dash x plus a2x y1x, provided that a2x not equal to 0. This is given. The given condition is a0x not equal to 0, and this is naturally hold because this is a ODE of degree 2, so a0x not equal to 0. And similarly for y2 double dash x equal to 1 minus a0x e1x y2 dash x plus a2x y2x. Now we put y1 double dash and y2 double dash in equation 2 in this equation. So we get Wronskain dash x equal to y1x into minus a1x a0x y2 dash x minus a2x a0x y2x minus y2x into this becomes minus a on x a0x y on dash x minus a on x a0x a on x a0x to y on x. So sorry, this is a2x. So this became a on x a0x y on x y2 dash x plus a2x a0x y on x y2x minus minus plus a on x a0x y on dash x y2 x minus minus plus, sorry, this became minus plus a2x a on x y on x y2x, and these two terms are cancelled out, and so this becomes, if we common minus, so a0x and y on x y dash x minus y on x y on dash x y2x, and look at this is the Wronskain because Wronskain of x equal to this, so we put it, so we put here minus a on x a0x into Wronskain of x. So from this we get that, so y dash x minus a0, sorry, a on x a0x omega, and this imply d of Wronskain of x dx equal to this a on x 0x kind of x, and this implies Wronskain d into d of this means derivative of this Wronskain of x minus a on x a0x dx. Now if we integrate in both sides, so Wronskain of x equal to minus integration e on x a0x dx, and here we called constant a, and this become log of Wronskain of x, and this became e on x a0x dx plus a. Now we put a equal to log of c, so here a is a constant 0x dx into log of c, put a equal to log of c, so Wronskain of x becomes c into e to the power minus e on x a0x dx, as c is a constant. Now this term this is always positive, so the sign of this Wronskain depends on this constant c. If c greater than 0, then Wronskain greater than 0. If If c less than equal to 0, then Wronskain of x less than equal to 0. So Wronskain of x totally depend on this sign of this Wronskain totally depend on this c, So this is more clear if we solve a problem. Now here I write a problem, that is, let y and y2 are two linearly independent solutions of the differential equations x square y double dash, that means d square dx square minus 2x y dash minus 4y equal to 0 for x belongs to 1 1 10 in closed interval 1 to 10. Consider the Wronskain w of x equal to y1 y2 dash minus y1 dash y2. If Wronskain of 1 equal to 1, then find the Wronskain of 3 minus Wronskain of 2. First of all, we read the given equation 2x y dash minus 4y equal to 0, and this below. Now we compare it with our given equation, and we compare a0 a1 and a2 the given problem. So here a0x equal to x square, a1x equal to minus 2x, and a2x equal to, and you see that the Wronskain does not depend on this. So now Wronskain of x equal to c into e to the power minus a1x minus a0x dx, and this became e to the power minus integration of a1 means minus 2x and a0 means x square dx. So this became integration 2 x dx x square, and this becomes c e to the power 2 2 not 2 log x square, and this is simply c x square. Now by the given condition Wronskain of 1 equal to 1, so we put here Wronskain of 1 equal to c into 1 equal to 1, so this implies c equal to 1. So Wronskain of x became x square. So Wronskain of 3 minus Wronskain of 2 is equal to 3 square minus 2 square, and this equal to 9 minus 4, this equal to 5. So the right option is 5. Now the next problem is, let p of x y double dash plus qx y dash plus rx y equal to 0, where px qx rx are real valued continuous function on x on real field. Then which of the following is a Wronskain of the given differential equation? This is very easy problem. If first of all Wronskain of x equal to c into to the power here qx px dx, where px not equal to 0. Now the sign of the Wronskain depends on these vectors, this vector, not vector, this quantity. This is always positive, so sign of the Wronskain depends on this constant c. So either c is positive or c is negative or c equal to 0. So we check the option. First of all, y of Wronskain of x equal to, if Wronskain of x equal to sin x, x real number, then this must be positive, negative and 0. So here Wronskain greater than 0 for some x, Wronskain less than 0 for some x, and Wronskain of x equal to 0 for some x. So this is not hold. So option A is false. Similarly, option C is false because this is hold for. So for this case, Wronskain of x not equal to cos x, because Wronskain of x greater than 0 for some x, Wronskain of x less than 0 for some x, and Wronskain of x is equal to 0 for some x. When we take Wronskain of x equal to cos x, and since Wronskain of x equal to this, and you know that either Wronskain x is positive or negative or 0. That means the sign of the Wronskain is always remains same. So this is also false. Now, if we take Wronskain of x, if we take Wronskain of x equal to 2x minus 1, where x belongs to cost interval 0 1, then you see that for cost interval 0 to half, Wronskain of x 0 to half, Wronskain of x is less than 0, and at x equal to half, Wronskain x equal to 0, and for half to 2, half to 1, Wronskain of x greater than 0. So therefore the sign of the Wronskain of x over this interval is not remain same. So this is not right option. So this is not also right option. Since here Wronskain of x is equal to some constant, so this is the right option. Thank you.